One more time. We have y equals the square root of x minus 3 after a horizontal stretch by a factor of 4 about the y-axis and a vertical stretch by a factor of 2 about the x-axis. So let's just start with a vertical stretch by a factor of 2. That means the entire original graph will be multiplied by 2. So we're going to put a 2 out front. And then they're also saying that there's a horizontal stretch by a factor of 4. But we have to remember horizontal stretches, we take the reciprocal of. Okay, so it's going to be instead of x, we sub in a quarter of x, showing that there's a horizontal stretch of 4. Then we can simplify this, so we're going to multiply the 2 out to each term. Okay, and we get 2 square root of quarter of x minus 6. Can we simplify further? Yes? Okay, let's just look at the square root of a quarter to start with. That can be rewritten as the square root of 1 over the square root of 4. The square root of 1 is 1, the square root of 4 is 2. So it can be reduced to 1 over 2. So we get 2, and then the square root of 1/4 became a half, and then we still have the square root of x minus 6. So 2 times a half is just 1, and we're left with the square root of x minus 6. So if you can simplify anything, make sure you're doing it. Okay, the last one, we're starting with the graph y equals 3x plus 7, and we have to find the equation after a vertical stretch about the x-axis by a factor of 1/3 and a reflection in the x-axis. So everything's going over the x-axis, which means we're playing with the y-coordinates. Okay, so that means everything's going to be vertical. So we have y equals, if we're dealing with the vertical parameter, is it going to be outside the original function or inside? Outside, good. Okay, a reflection is shown by a negative, and we have a stretch factor of 1/3, so that's going to go on the outside of the original function, 3x plus 7. Lastly, just clean things up, distribute the negative 1/3 through each term. And we get negative x minus 7 over 3. Okay, the 3's here cancel out. Alright, moving on, more practice. So this time we're given 2 graphs, and we just have to describe what is happening from one graph to the next. So the first function in part A is given as y equals f of x. The second one is y equals f of half of x. So it's inside the function, horizontal stretch, and that's about the y-axis by a factor of, is it a half or is it 2?
2.
Good. Horizontal stretches, we take the reciprocal, so it's by a factor of 2. Okay, moving on to B. We have y equals to the power of x. That's our original graph. The image is y equals 2 to the power of 3x. So as you can see, x has changed to 3x. So if x is changing, we have a horizontal stretch. Okay, and that's about the y-axis. And that's by a factor of the reciprocal, which will be 1/3. So anytime you have a stretch on the x values, you always take the reciprocal. Okay, next up, we started with y equals the absolute value of x. And the new image is y equals -2 times the absolute value of x. So the absolute value of x is still the same. Nothing has changed inside the function. But we have a -2 multiplied by that function. So that should automatically hint that you have a vertical stretch. Okay, and vertical stretches occur about the x-axis. And it's by a factor of 2. Vertical stretches, as long as the number's on the right-hand side of the equation, you take the actual number. Okay, is there another transformation? What's happening?
Reflecting in the, no, maybe I
Okay,
don't know.
if it's outside the function, is it affecting the y values or the x? Good, the y values, which means it's
So
a
X.
vertical reflection. It's going over the x-axis. Okay, so reflection over the x-axis. Okay, so two things were happening this time. Okay, let's look at the next one. Y is equal to x cubed, and the new image is 3y equals x cubed, or yeah, 3y equals x cubed. So what I'd recommend you do is right away, just write this as y equals. So divide by 3 on both sides, and you get 1 over 3 times x cubed. It's outside of the function, so that should, or it's multiplied by the function, so that should imply that you have a vertical stretch about the x-axis. And this will be by a factor of 1/3. Okay, E, we're starting with the absolute value of x, and then we have y is equal to 2 times the absolute value of 1/3 of x. So we have two stretches happening. We have a vertical stretch shown by the 2, that's our A, and we have a horizontal stretch shown by the 1/3. Just remember, with horizontal we take the reciprocal. Okay, so we'll start with a vertical stretch. It's about the x-axis. That's by a factor of 2. And then the second stretch will be a horizontal stretch. That's occurring about the y-axis. And this is by a factor of the reciprocal of 1/3, which is 3. Last one, we've had lots of practice, you guys can help me out. So we have, again, the y equals the absolute value of x, but our image is y equals the absolute value of -2x. Inside the function, we have a stretch factor, and we also have a reflection. Where are we reflecting over? Good, x is changing, so that means it had to reflect over the y-axis. Okay, and again, it's inside the function, so x is being replaced with -2x. That's telling us we have a horizontal stretch about the y-axis by a factor of 1/2. So Emily, now that we've seen a few examples, is it starting to come together?
Yeah, I think so.
So which parameter takes the reciprocal?
X.
Okay, so the B parameter,
Yeah.
which is affecting the x value, good, and that's a horizontal stretch. Okay. So anytime you see the words horizontal, think about the reciprocal.
Yeah.
Alright, so sometimes looking at equations can be a lot easier because you can just plug it into your calculator, or you can, and then you can test it out. But when you're given a graph, it's really important to know the skill of point mapping. Okay, so we're going to look at a point and see where did it go. And after that, we'll be able to tell our transformation. So in this question, we're looking at the original graph, which is in the thin line, and then comparing it to the image, or the transformed function, which is in the thick line. Once we figure out what's going on, we have to write a new equation for the transformed graph. Okay, so can you guys tell me, do you think this is stretching vertically or horizontally? Vertically. It looks like it's getting, well, it started here, now it's shorter, right? So it was tall, now it's short. Okay, so there was a vertical transformation, okay, a vertical stretch. Let's just look at the original point of the y-intercept. We're starting at 0, 6, and we're ending at 0, 3. So the y-intercept is now half of what it was. So we can say that there was a vertical stretch by a factor of 1/2, and this is about the x-axis. Hi, Judy.
We were wondering if we could borrow Jane for like 2 minutes.
How come everyone's borrowing Jane?
Really?
Yeah.
3 groups then.
Oh,
Yeah.
I mean, we can use someone else. I just, the first person was Jane.
Sure.
Really? Heavily. Oh, okay.
If you're okay with missing part of the lesson, then yeah.
It's like 2 minutes. She
Okay.
works.
Sounds good.
What?
I apologize to anyone watching the video because it's very disruptive. Okay, so we did our vertical stretch. Let's just talk about point mapping as well. So we have an original point xy, and is anything happening to the x-coordinates? Nope, so that one's going to stay the same. But what's happening to the y-coordinates?
It's getting smaller.
Yeah, smaller by a half. So you're multiplying by a half. Good. Okay, so if we have a vertical stretch of a half, how are we going to rewrite this equation showing the transformation? We started with y equals 6 over x squared plus 1. What's our new equation? Good. We're going to multiply half times the original function, 6 over x squared plus 1. Awesome. If you did want to simplify that, 6 divided by 2 is 3. So you could have written it as y equals 3 over x squared plus 1 as well. But it's nice to leave it in this form sometimes because you're seeing what you're stretching by. Okay, B is probably the most challenging of them all, so I'm going to skip that one, and we're going to go right to C and then back to B. Okay, if you look at this graph and you check out the range, has there been a change in the range? Okay, the highest y to the lowest y. Is the range changing from the thin graph to the thick graph? No, it stays the same. So nothing's happening vertically. We're not stretching so that the y coordinates are getting bigger or smaller. But what about going from the thin line to the thick line? What's happening to the x coordinates? Okay, good. So the x coordinates are stretching, which means we have a horizontal stretch. Also, let's just make sure we're asking, are there any reflections? Take a look at the arms on the original graph. Okay, so on this side we're pointing up. On our image, again, we're pointing up. No reflection on that arm. Okay, this arm's pointing down. Again, on our image, it's pointing down. So there weren't any reflections. So all we can notice is that there's a horizontal stretch. Now we just have to figure out what that horizontal stretch was. So let's start at an x-intercept because that's pretty obvious. Okay, so here we're starting at negative 4, 0, and our new x-intercept is at negative 8, 0. Let's just test to make sure it's the same stretch factor on all the x-intercepts. Okay, here we're at positive 6, 0. Our new one is at, if you count over, should be at 12. So 6, 7, 8, 9, 10, 11, 12, yep, we're at 12, 0. Okay, so 2 to the 3 x-intercepts have been multiplied by 2. So we can conclude that there's a horizontal stretch about the y-axis by a factor of 2. If we were talking about point mapping, x, y would go to 2x and y would stay the same. Okay, they've given us the original function as well. Okay, y is equal to x plus 4 times x minus 2 times x minus 6. We need to apply this stretch factor. Okay, it's a horizontal stretch, so are we going to have a factor multiplied in front, or will x be replaced with a factor? You guys are easily distracted. Okay, I'll ask again. Will the stretch factor be multiplied out front, or will all the x's be replaced? Good, it's a horizontal stretch, so all the x's are being replaced. Okay, and we agreed that the stretch factor was 2. What we're going to sub into our equation is the reciprocal of that. So we have half of x plus 4 times half of x minus 2 times half of x minus 6. All the x's were replaced with half of x. We can clean this up a bit. From each binomial, we can factor out a half. So if I factor out a half from the first binomial, half divided by half is 1, so we're left with x. 4 divided by half is positive 8. Second binomial, we're going to factor out a half. Okay, we're left with x as my first term. Negative 2 divided by a half is negative 4. Last binomial, let's factor out a half. We're left with x, and negative 6 divided by a half is negative 12. This is jumping a little bit ahead, but in one of our units, the polynomials unit, we're going to be looking at cubic functions. And I just want you guys to look at these factors here. So x plus 8, x minus 4, x minus 12. Do you see any similarities between these factors and the new x-intercepts? Okay, if we took the opposite sign, we'd get positive 12, x-intercept at 12. Okay, if we took the opposite sign, we'd get 4, x-intercept at 4, negative 8, x-intercept at negative 8.
Do you have to take the half out? Like, do you have to?
Typically, you will have to simplify things
Okay.
like that. This actually isn't completely simplified yet because we could take the half times a half times a half. Okay, so 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So we have 1 over 8 out front. And then we're left with our factors x plus 8, x minus 4, and x minus 12.